This is not just a house. It is a shape that has quietly outlived storms, fire, time, and the modern building industry itself. Certified to resist the most violent tornadoes and strongest hurricanes, this structure can slash energy use, lower maintenance, and stand for generations. Yet almost nobody builds one. In a country filled with fragile wooden boxes, the most resilient home on Earth remains a rarity. The question is simple. If a safer, stronger, and more efficient design already exists, why are we still building homes that fail in wind, burn in fire, and drain money every month? To answer that, we have to go backward, far beyond suburbs, mortgages, and modern construction codes, to one of the oldest ideas humanity ever discovered. Long before concrete, steel, or engineering textbooks, early humans learned that curved shelters worked. In freezing plains and violent weather, rounded forms shed wind, carried weight more evenly, and survived conditions that punished flat walls. The dome was not invented by modern architects. It was observed in nature, tested by necessity, and refined by civilizations over thousands of years. The Romans understood this deeply. When they built the Pantheon, they proved that a dome could endure across centuries. Earthquakes, storms, invasion, and time itself failed to erase the logic of compression and curvature. The same principle appeared again in igloos, ancient huts, and traditional structures across harsh climates. Again and again, the lesson was the same. When force arrives from every direction, a continuous curve answers it better than corners ever can. In the modern era, a few builders revisited that forgotten wisdom. Early experiments showed promise, but many designs relied on too many joints, too many seams, and too many failure points. The real breakthrough came when innovators stopped trying to assemble a dome from pieces and instead created a single continuous shell. That changed everything. The process begins with a circular ring beam anchored in the ground. A custom fabric membrane is attached and inflated, turning an empty foundation into a giant pressurized form. From the inside, workers spray foam across the curved surface, building insulation and rigidity at the same time. Rebar is tied throughout the shell, then shotcrete is applied in dense layers until the whole structure becomes one seamless mass of reinforced concrete. That single detail matters more than most people realize. In a normal house, insulation sits inside the wall, while the building frame remains vulnerable to outside temperatures. In a monolithic dome, the insulation sits outward and the concrete mass stays inside the thermal barrier. That means the interior stores warmth and coolness like a battery, releasing energy slowly over time. The result is a home that feels stable, quiet, and efficient in both summer and winter. But energy savings are only part of the story. The true power of this design appears when nature turns violent. Wind does not slam into a broad, flat wall, it flows over the curve. Pressure does not collect at corners because there are no corners. Fire finds little fuel in a reinforced concrete shell. Rot, termites, and moisture damage lose much of their power when wood is removed from the equation. A dome is not merely different, it is structurally aligned with the forces that destroy ordinary homes. And this is not theory alone. Real domes have survived extreme storms that shredded nearby buildings. Others have endured brutal heat with surprisingly low energy bills. Across different climates and countries, these structures have served as homes, schools, churches, and community spaces. Again and again, the same pattern appears. While standard construction struggles against the environment, the dome works with geometry to reduce the environment's advantage. So why is it still rare? The answer is not physics, it is bureaucracy. Modern housing systems were designed around repetition, resale, and comparison. Appraisers want nearby houses that look the same. Lenders want familiar categories. Zoning rules expect standard roof lines. Inspectors often review square houses every day, and domes almost never. When a design falls outside the template, the system treats innovation like risk. That creates a trap. Because few domes are built, there are fewer sales to compare. Because there are fewer comparisons, financing becomes harder.
Because financing becomes harder, fewer people build them. The cycle repeats, not because the structure fails, but because the market rewards conformity over resilience. Still, for people willing to think long-term, the dome offers something modern housing rarely does: durability, efficiency, and peace of mind. A home designed not for fashion, but for survival. Not for rapid turnover, but for decades of use. Not for appearances, but for performance.
The most surprising part of this story is not that such a house exists. It is what we have known for thousands of years. We solved this problem once, then built a system that forgot the answer. And maybe that is the real reason this shape feels so radical today. It is not futuristic. It is ancient wisdom returning in concrete, steel, and air. If the future of housing is supposed to be smarter, stronger, and more efficient, then perhaps the future is not a new invention at all. Perhaps it is a rediscovered curve, waiting for people brave enough to build what works instead of what is normal. Every image in this story points to the same conclusion. Strength is not always expensive, efficiency is not always high-tech, and progress is not always a straight line. Sometimes the best answer is the one history already tested, nature already approved, and modern systems simply learn to overlook. The dome stands there like evidence, asking one final question. If this works so well, what else have we been taught to ignore? That question may shape the homes of tomorrow.